Hello guys, how are you doing? Welcome back to this amazing YouTube channel. My name is Lona and I'm a cloud engineer. And in this video today, I want us to look at the basics of Amazon Elastic Container Service. Just an introduction to Amazon ECS. So Amazon ECS is a fully managed container orchestration service that you can use to deploy your containerized applications. So just like Kubernetes, for some of you who've used Kubernetes, you'll very easily relate with Amazon ECS because just like Kubernetes is a orchestration service for Dockerized applications or containerized applications, Amazon ECS is also a fully managed service that you can easily use to deploy your containerized applications. So looking at the documentation from Amazon themselves, they defined Amazon Elastic Container Service as a fully managed container orchestration service that helps you to easily deploy, manage, and scale containerized applications. So as a fully managed service, you have to get that. ECS comes with AWS configuration and operational best practices built in. So it will make it very easier for you to easily run your containerized applications as opposed to when you're doing things manually on the side, maybe when you're running your own installation of something like Kubernetes or Ranger or any other. So with Amazon ECS, you'll find it quite easy to just, follow a few clicks and you'll be able to deploy your containerized applications. So I just want to do a quick demo and also maybe just define a few terminologies used by ECS and also correlate with Kubernetes so that for someone who's already using Kubernetes, it can become easier for you to understand. So I'm not going to go into so much details because there's a lot of things that you can do with Amazon ECS, but I'm just going to do like a basic introduction, and then maybe in the next videos you can continue to see how some other things that you can do with Amazon ECS. So the first thing that you find when you go to ECS page, let me just go there, Amazon ECS. So the first thing that you do, or you know by default when you need to deploy a containerized application, is that you must have an image. So for my case here, I just created a simple image also in Amazon ECR so that we're going to use for our demo. And number two, you also know that you need to have like the infrastructure, like the cluster. So the cluster will consist of the base nodes that the applications will run on, and some of the applications that are needed to be installed in those nodes so that you're able to run your containerized applications. So in this case, Amazon ECS uses Docker in the background, and it also uses Amazon EC2 instances. So when you're running your containerized applications with Amazon ECS, you can either choose to use Amazon ECS with EC2 instances that you have more control over, or you use Fargate, which is a serverless service that you can also still use to run your containerized application. So with serverless, you don't have to worry about the infrastructure, but with Amazon ECS on EC2, you have more control of the nodes that eventually will run your containerized applications. So I'm going to demo for both, maybe just do a quick demo for both Fargate and EC2 instances. So when you have your account, definitely you need to have a VPC where your container applications will run on. For Fargate, something I have to mention is that with Fargate, which you also need to go and read from the documentation, is that with Fargate you can also only use Amazon VPC as your network mode. With Amazon ECS on EC2, you can have more flexibility of using different networks like hostnet network and things like that. But just go to the documentation, AWS documentation for Amazon ECS, and see the difference when you're using Amazon ECS on Fargate and Amazon ECS on EC2, and you'll get more insights. And the good thing about AWS documentation is that they give a lot of information, and you'll never go wrong from reading AWS documentations on any AWS service. So let's get started. So going to ECS console, rather page, this is it. So the first thing that you meet is asking you to create a cluster. I've already explained that a cluster will, of course, the first thing you need for your cluster is the base infrastructure. So if I click on create infrastructure, it will ask me for infrastructure name. Let me say ECS test. And then now it asks you to choose your infrastructure. Are you going to use AWS Fargate, which is a serverless service, or you're going to use Amazon EC2 instances where you can have more control of the instances that are going to run your application. So let's start with EC2 instances, for example. Let me do that. And then when you choose Amazon EC2, you have more to choose. You have more options to choose. So for auto scaling, of course, we say that Amazon ECS is scalable, so you can choose auto scaling so that when your tasks grow, then the base infrastructure will also grow. So I'm not going to, I don't have any, so let me just say create new auto scaling group, and then you choose the pricing model for your EC2 instances. So I'm just going to go with on demand. So for maybe applications that don't require to be online all the time, or maybe for just your test, or for your development purposes, you can go with spot, and you know how much you can save with using spot instances. But let me just go with on demand. And then the container instance AMI that I'm going to use. So let me just select Amazon Linux 2. Something that I have to mention about this is that remember I said when you for your infrastructure it has to run some applications so that you'll be able to have your container applications running. So one of the things that run in the AWS nodes is an ECS agent, Amazon Linux ECS agent. So it's basically the agent that communicates with ECS for you to be able to run your applications. Just like in Kubernetes, when you have kubelet. So kubelet, we know that it communicates between the worker nodes and the control plane to facilitate running of your container. So the same thing with ECS, we have what we call ECS container agent. So this one, with this, the good thing with using Amazon ECS is that you can actually use what we call AMIs that already have support for ECS. So in this other documentation, you can see Amazon ECS optimized Linux AMIs. So when you use this kind of AMIs, they already have the agent installed, and the other things that are needed for your cluster to run your containerized applications. So if you do things manually on the side, for example, you create your own EC2s without choosing these ECS optimized AMIs, then you might have to go an extra mile of doing the manual installation of the agent. That might, give you some problems. So what I usually recommend is that just use the ECS optimized Linux AMIs. And the good thing also with this one is that the ones they have new updates, AWS usually communicate for you to be able to use the new AMIs that have the new features. Yeah, that's just something I wanted to mention. So let's go back to our cluster. So Amazon Linux 2 already is an ECS optimized AMI, and then you choose the type that you want. Do you want like one VPC and one memory? You can always make different selections over here. So let me pick C3. So once you choose the instance type over here, the next is for you to choose ECS instance role. So an ECS instance role is used by Amazon EC2 instances to make AWS API requests. So let's choose this one, which is already here. But you need to read more from the documentation to understand why you need EC2 instance role. And then the capacity, remember up there you chose to create a new auto-scaling group. So what's the capacity that you want for your EC2 instances? So I can say I want a minimum of 1 and a maximum of, say, 3. So every time I have my container scaling up, the auto-scaling group will also scale up my nodes or scale down accordingly. And then do I have, yeah, you need to be able to SSH also into the nodes. So I don't know if I have this. Let me just create a new one to be sure. Because I'm choosing EC2, sometimes you need to SSH into the EC2 instance to check whether the agent is running and things like that. So let me just say ECS test. And let me just use APK so that I can use party, and then let me create it. So I'm done. So I'm just going to select it from here. And then the root volume for the root EBS volume, let me just, by default it gives 30 at a minimum. So if you want to give more, you can do that. And then the VPC, I created this VPC for this test, ECS test VPC, and I'm going to choose public subnet because I just want my application to be available on the internet. Remember also, you can choose to go fully private, but I think I'll also do a video on that going forward so that I can show you how to use VPC private links when you have a fully private cluster. But for now, being just a basic introduction, let me just do public, and then That's the security group which I have, and then assign IPs to the cluster, to the nodes. Yeah, I want to assign the IP addresses that I should SSH whenever I need to, and then create the cluster. Right, it's just for feedback. So my cluster is creating. It will take some few minutes to create. I have an error, service unavailable, please try again. Yes. No service exception, I don't know what this means. Let me try again. Oh, it's actually created. Oh, okay. Let me go back and refresh. It's telling me it already exists, so let me check. Why? Let me give it another name. So let's hope this one is going to create. Let's give it a few seconds. So as you can see, our cluster has successfully created. So the next thing that we are going to do is that we need to create what we call a task definition. So before you create a task definition, let me also explain a few things. So with Amazon ECS, we see that we need a cluster. So we have a cluster, you also have what we call a task, and then we have what we call a task definition, and then we have a service. So a task is basically like a pod in Kubernetes. So if I compare with Kubernetes, it's like a pod. So a task is composed of one or more containers. So in Kubernetes, that is what we call a pod. Now, a task definition now explains what we need to be able to run our tasks. So in terms of the image, the environment that we are going to use, whether it is EC2 instances or Fargate, in terms of maybe resources that we want to give to our container, all that is defined in task definition. So once you use a task definition, it will create for you a task. So in Kubernetes, we have what we call a manifest. So it's the same thing. So with a manifest, you define everything that you want to do. You want your container to have. So in this case, we call it a task definition. And then we have what we call a service. A service in ECS, please don't confuse with the service in Kubernetes. A service in ECS is basically like a deployment in Kubernetes. So service enables you to create replicas of your task. So you can say you want maybe 5 replicas of your task, and also when the task fails, when you run it with a service, it's going to be able to be brought it up by ECS. So it's basically like a deployment in Kubernetes. We know in Kubernetes, when you use a deployment, you're able to define how many replicas, and also you define the rollout so that if a task fails, another one should be created. So a service in ECS equates to a deployment in Kubernetes. Task definition in ECS equates to a manifest in Kubernetes. A task in ECS equates to a pod in Kubernetes, and inside a task we have containers. So I hope that is understood. But also please visit AWS documentation. You will find all those definitions of all the terminologies that we use in Amazon ECS. So let's start by creating our task definition, which I said is basically like an we are defining things that we want our containers to have. So you come here and say create a new task definition. You can create with JSON or just create from the console. So let's go ahead to create our task definition. Last time we call it ECS test. And then I'm going to choose EC2 infrastructure because I haven't created yet an Amazon Fargate infrastructure. And then the network mode, remember I said when you're using Amazon ECS on EC2, you have an option to actually choose a different type of network mode. But with Fargate, only AWS VPC is available. Please go to the documentation and read why that's the case. And then the CPU and memory that I'm going to allocate for my task. Remember, I said task can have one or more containers. So depending on how many containers that you want inside your task, then you need to allocate CPU and memory accordingly. I'm just going to use 1 vCPU and 3 memory as it is. And then we need to have a task role and a task execution role. So Amazon ECS require roles. So there are different things that Amazon ECS need to do. For example, pulling image from ECR and also even sending logs to CloudWatch and things like that. So you require a task role and a task execution role. So task role allows containers in the task to make API requests to AWS services, and then execution role enables container agents to make AWS APIs. So I'm just going to say create new role, and then for this one I think I'll locate it later, but make sure that you have a task role and a task execution role. Go to the documentation and read why you need a task role and a task execution role. I think I had opened that documentation somewhere here. Where is it? Where is it? Yeah, this one, Amazon ECS task execution role, and also check on task role. You need those two to be able to have your containers running. So for this, I'm just going to say create a new role, and then for this one, I'm going to append it later. And then I'm going to, as I said, I don't want to go into so many details. There's what you call placement constraint. So for example, if you're on your task, maybe you want to have 5 nodes in the cluster, but you want a specific node to run this particular task. So you can actually do what we call placement constraint to limit your task to run on specific instances, but I'm not going to do that for now. And then now this is the container part. Remember, this is the task, and now we are defining here the containers that we want to run inside that task. So I'm going to name it maybe just 1. And then the image URI, I'm going to go back to my ECR and pick the URI for the image. Yeah, this one. So I copy the URI and take it back here. And this is my essential container. So every task needs to have an essential container. That's the main container, because sometimes you can have the sidecars. You can have the main container and have the sidecar. So you have to declare that this is your essential container. So for me, it's an essential container. It's going to be on port 80. So you choose your ports that you want your application to run on, and you can have for the container as well. Remember, we set the resources for the task, but you can also set resources for specific containers. For CPU, if you require GPU, memory, head limit, and things like that, but I'm not going to set because this is just a basic demo. But you need to, it's always important to set resource limits for your containers as well. And then if you have environment variables, you can add here. If you have an environment file, you can also add here. So for these environment files, the documentation says that you need to save it on S3, and then you can reference it here. So you can see it's referencing S3. So you have, maybe you've written your environment variables on a separate file and you saved it on S3, you can reference it here for your containers. And then for log collection, you can just use the CloudWatch or any, a different log driver that you can use. So ECS also support different log drivers like FluentD and things like that, which you can also find in the documentation. Just search on the log drivers that ECS supports. So if you don't, maybe you don't want to use just CloudWatch, you want to use something else like FluentD or a different log collector, check if ECS supports that particular driver. So for me, for now, I'm just going to use a CloudWatch, and then I don't have to set any of these. I don't need volume, so create a task definition. So you go and say create. Oh yeah, I don't need this, sorry. Create. Yeah, so we have our task definition. This is it. So every time you come and update this task definition, we'll find that it will create a new revision of the task definition. For example, maybe you want to change the image or you want to update something, you just come and update the task definition and it will create a new image. So if you have like an automatic rollout, the moment you change the task definition, you'll realize that a rollout will start. Now, the next thing, now that we have our task definition, then we now need to create our task. So remember I said you can create a task, a standalone task, just like a standalone pod in Kubernetes, or you can create your tasks using a service. Just like in Kubernetes, you create pods using a deployment. So when you want to have like a more managed containers running, you always advised to use deployment in Kubernetes as opposed to running standalone tasks. So the same thing also applies to ECS. If you want to create a standalone task, just create a task. If you want to create a task that is managed by a service, then you create a service. So you're going to come here and say choose our cluster. And see, we have a service, we have a task. So let's create a task first. So a task is a standalone, just a standalone task. So you just like run new task, just like the way you say kubectl run this. It will run one standalone pod. So you can just come and say run new task, and then there's what we call capacity provider. As I said, ECS has a number of things. Capacity provider basically is where your containers will run, and you can choose to. So that you can have Fargate and you can have ECS as your base infrastructure, but you can also have a mix of ECS and Fargate in your cluster. So, but when you're choosing a strategy, you just have to choose either ECS, EC2 or ECS Fargate. But please, I don't want to go into so much details on this, and it's advanced. But maybe in my next videos, I'm going to go inner into some of the things that you can actually find really nice with Amazon ECS. But for now, let's just do the basic demo. But go into the documentation and read about capacity providers in Amazon ECS. All right. So you can choose capacity provider, or you can just go with the launch type. So for our launch type, I have EC2. I don't have Fargate infrastructure. I had EC2, and then we are running task, just a standalone task. As I said, if you want to manage tasks where you can easily scale out or scale in, you choose a service. So we just want to demo with a task, and then task definition. I created a task definition that we're going to use, and it's the only revision that I have, the latest. If I had another one, I was going to be able to choose the new revision over here. And then desired tasks, let's say one for now. Task group is not really necessary. Networking, I have my VPC. And then I'm going to just choose the public subnet for now. And then an existing security group, I have a security group over there. And then you can also go through some of these options, but I don't have to go into details for now. So let's create our task. So this is a standalone task. As I said, if I compare with Kubernetes, this is like a single pod which is not managed by deployment. For deployment in ECS, we use what we call a service. So my task is in provisioning mode. So let's give it a few. Yeah, so it's already running. So that's it. That's it. It's as simple as that. It's as simple as that. So in terms of now checking on your service, maybe from your browser, because this is just a simple app, you can choose to use maybe a load balancer, but there are also different ways in which ECS expose your applications, which you can also check on, and maybe also going forward, I'm going to do those videos as well. So for now, it just has to make sure that we have a running task in with ECS, and that's it. So let's also create using a service. As I said, in comparison with Kubernetes, a service is like a deployment. So you can have, your replicas of the task defined in your service. So let's do with a service as well. We've seen that our task is running, our standalone task, but let's also test with running a service. So we have our task definition over here. So I'm going to create the service. So create, so you're in service, and then create. And then I'm also going to still use launch type and choose EC2. And then it's a service. The other time we did a task, so it's a service in this case. Choose our task definition, a service name, you can say ECS test, and then a replica. Remember, a replica here enables us to have more than one replica of our task. If you just want to run a diamond set, diamond set just have one container running each and every node. You can use diamond, but in this case, let's do a replica. How many desired tasks do we want? So let's do 2. And then these are some of the things that are really important when you're using ECS, especially in a production environment. So read about Service Connect, read about service discovery. It's just the way that we discover our containers within the cluster. Just the same way in Kubernetes, we have different means of discovering or rather connecting to our services in a large production environment. So this one also are also available with ECS. So go ahead to the documentation, read about Service Connect, read about service discovery, and also load balancing, using load balancing. So for our case, I'm not going to go into so much details on these ones, but going forward, I'll actually be maybe doing one video for Service Connect. Next time I do a service for service discovery as we go ahead like that. So let's just pick our network. So we have our VPC, and I'm going to select the public subnets for now because it's just a simple demo. Sometimes also when it's a production environment, you know, there's some things that you may not want to expose to the internet. So you may find that your VPC is fully private. And with that, when you're working with Amazon ECS, you need to have maybe private links for you to be able to connect to ECR, for example, CloudWatch and things like that. But for my small demo here, let's just go with public subnets for now. And then click create. So let's see our service. Give it a few minutes to create. Oh yeah, so I had created a service with this name and it's telling me it's in the process of deleting it. So let's give it a different name. Let's give it a different name. Let's see. Where's the name? Where's the name? Where's the name? Yeah, here. Let's give it ECS test 1 and create. So our service is in progress of creating. Give it a few minutes. So as it continue creating, I just wanted to mention something. You can see here we have registered container instances as 1. So when I created my cluster and created the cluster with EC2 as opposed to Fargate, you need to be able to see registered container instances showing a certain number. So I'd given my auto-scaling minimum of 1 and a maximum of, I think, 3. So you need to be able to see that your containers are actually registered to the cluster. So if you don't find containers here registered to the cluster, you will not be able to create your task. You will get an error like the task do not have container instances. There are no container instances for your tasks to run on. So one of the things that can cause this is probably the ECS agent is not running well inside the container instances. And maybe it's in a situation where you did it yourself manually. Maybe you just created your own EC2 and then try to install the ECS agent there by yourself. So sometimes you may find that the ECS agent is not running as expected, and so it's not enabling your container instances to register to the cluster. So that's one of the possible reasons. Another reason could be your network. There's no communication between your container instances and the EC2 agent. So for example, if you're running in a fully private network, you need to either have a NAT gateway or private links to enable that communication. So those are some of the possible reasons, but you can also go online and see why you can get an error like there are no available container instances for your tasks to run on. So one is failing. What could be the reason? So we have one task running, the other one is failing. So here, when you come to events, you should be able to see what's happening within your cluster. So yeah, so one was started, the other one is having memory issues. So I think because of the small memory which I did. So my container is running on Ubuntu base image, so that's understandable. It could be running out of memory, but that's basically it. You've seen that you can actually run your containerized applications with Amazon ECS using standalone tasks and using service on Amazon ECS with EC2 instances. So in our next video, I'll do a demo for Fargate. So this was a demo for EC2, and with EC2, I see that you have more control on the container instances. If I go back to EC2, sorry, EC2. You can see that I have an instance running. This is the same instance that my containers are running on. So because I'd given in my auto scaling a minimum of 1 and a maximum of I think 3, if my tasks scale out, you should see that it will be creating more instances here for you. So this one you have more control because you can actually SSH to this instance with the IP address and check if it has any issues. You can check on the status of the container ECS agent. You can check on the status of Docker. You can check the logs if your containers are not maybe functioning well. You can even SSH exec to the container within your container instances. So that is it for running containerized applications on Amazon ECS using EC2 instances. So in our next video, please be on standby. I'm going to do a demo for Amazon ECS with Fargate, and I'll show you how to exec to your container instances using when you're running your containerized application using Fargate. So meanwhile, please, as I said, go back to the documentation, AWS documentation, how to run your container instances using Amazon ECS with Fargate. So we've seen how to run with Amazon ECS with EC2 instances, but there's so many other things that you need to learn. Of course, in a production environment, you need to be able to have containers communicating. You have different environments. Maybe you have, your backend applications, your front-end applications. So they start containers, applications discovery, which all of that are also possible with Amazon ECS. So go back to the documentation and read, practice on your own, and that's how you get these things, how they work. So thank you so much for watching up to this far. Please subscribe to my YouTube channel and please share the videos as much as possible. Until next time, bye.